In this chapter, we focus on objects as opposed to our work with our functions in previous chapters. Here are our weekly media learning goals. The idea of object-oriented programming is to represent things as they are in the world. I have previously discussed looking at the coding process as a to-do list with your most important tasks listed first. Our object-oriented program has us implement our analysis. In other words, we act on our plan to address our problem. The point here is we want to be able to address all problems which may come our way. Sketchpad was the first object-oriented program. Here you see what Sketchpad can do in action. Many programs now have a similar art tool within them. The second object-oriented program, Simula, allowed to test real activities as steps. In addition to his programming work, Alan Kay has also done great work with GUIs, which is short for Graphic User Interface. Computers were seen as devices which could store data and complete tasks even before you were born. Innovations continue to this day. Computers were initially very big because they needed to be powerful enough to send data to each other. Objects make it easy for us to reuse code because they address a specific task. Many of Kay's ideas were initially just dreams, but now you can actually buy a Dynabook. Here is a visual of the prototype. The Dynabook was developed initially to be an educational tool. Very few individuals around can program using Smalltalk 72. Can you find anyone who can? Computers were much harder to use back in the day. Objects are real-world things, such as, in this example, a turtle. We can bring turtles into our world using Python. Here, we create a turtle at a set pixel location. Here, we are drawing our turtle using our pen command. Here, you'll notice forward Tina, 100 makes something happen, and Tina.forward 100 simply suggests something happen. So the way we write our code impacts how it runs. Test these out. What happens? Are you making multiple turtles or just moving one turtle around? Can you figure this one out? Do you need draw, pen? What code do you need? Having previously made a turtle Tina, it is being moved around, while our new turtle Sue stays in its assigned pixel, as seen here. No matter how many turtles we create, they can all complete the same commands. Here, we see multiple turtles in action at once. Here, we use a chase function to create a path the turtles can take. Here is a visual of the turtles chasing each other based on our code from the previous slide. Can you figure out what mystery shape our code is creating here? As you can see here, we can even add a turtle into a picture. Notice our turtle. We are spinning our picture here and creating a turtle Ted. Here, our turtle draws a square for us because we asked him to. Here is a visual of the square our turtle made us. Notice our turtle is right where he started from. There's Ted. There's the square. Here, we are giving our turtle size parameters for our square. Here, our turtle draws 3 squares for us, all of different sizes. 1 square, 2 square, 3 squares. Can you draw a polygon in JES? Can you figure it out? Can you write the code? Since turtle is a class, through inheritance we can create a subclass which inherits all its commands. We import class random so we can use the random number generator within our code. Here, we're suggesting Goofy move, not demanding it, so the code may work differently. Remember recursion, where a function can refer to itself? Here is recursion in action, but in different ways. Here is another different way. You'll notice, by using the corner code, we've changed our action. While it is easier to inherit or use existing classes, we can also make our own. Try this code out. Does it work? In one respect, our code on the previous slide is good because we created an object slide, but in another sense, it is redundant. It is important to define an object based on what you want the object to do. Here is an example of what our slide knows and does. Think of all objects in these terms. We need to know what they know and what they do. Objects can utilize information from within a class. Here, we create a class named slide, but we need methods to do something. We have to implement our new class as a function. Here is an example of what this means. Notice slide1 equals slide here. We're using our object as a function. We eventually want to show our slide to see if our program's code is correct. Here, we use self as our input with the explanation described for you as y. The statement to show our slide is slide1.show. Always think about how to make your code better, or I've used the term smoother. Sometimes you want your code to give you more options or flexibility, so you need to adjust the code accordingly. We have now created a slide with our code here. We have now created an object in the form of 4 slides here. Recall map as our function from our discussion as apply, map, and filter from our previous chapter, chapter 16. Try this code out. Does it work the same as our code from slide 60? While correct, the previous code isn't the best for object-oriented coding. As you have seen with pixels, we can get and set certain variables. Are you up for this challenge? Objects help us take a real-world approach and helps in addressing redundancy issues. Without noticing it, you've been using objects all along through this course. We can use previously seen variables as objects too, if we so choose. Show acts differently depending on what our object is. We may want to use a method multiple times, like with show and a slide and a picture. This is polymorphism. Our if not statement does not run the show method unless we have a picture. As we have seen, pictures and colors can be polymorphic. We can use get and set within classes, functions, or objects. Methods may be easier to use in JES due to the sheer amount available to us. Here are some graphics methods for creating shapes. Rectangle, rectangle filled, oval, oval filled. Filled simply means that inside there is color. Here are some graphics methods for creating arcs. Text, as we have seen, also has its own methods. Here, we create a picture with two rectangles in it based on the parameters we've provided. Our filled rectangle and our regular rectangle. Try out this code for creating ovals. Do you get the same result? Try to see if you can create these arcs using this code. Do you get the same result? Text can be printed into a picture via our canvas we create. Refer back to our sunset function from chapter 4. Notice our code provides comments explaining we're using one method and not a similar method. Seen here. Our comment, and again, another comment. We create subclasses so they can inherit all the methods from a class. Here, we change the sunset from a function to a class. And utilize it as a method. Try out this code. What does reverse do? Objects are helpful in many ways. Here are some referenced for your understanding. Python acts differently than other programming languages. Inheriting classes helps open up more options for us to complete a task. Inheriting classes is taught to show you how the redundancy of a program can be limited. There are some clear situations where you want to use objects the other options we have described within this course. These reasons for why you may want to use an object instead of those other possibilities are described here.